This is Jim Chastain with EasyPower. Welcome to the EasyPower Tuesday Refresher Series. Today we're diving into a pile of the most frequently asked questions when it comes to arc flash and NFPA 70E. The list is surprisingly long, and I welcome everyone to the discussion. As we generally do, I like to start with a couple poll questions just to get a feel for where the audience stands as we're getting into this. And so the first question, if you would please help us with some feedback, relates to those of you that have had to navigate the update from NFPA 70E 2012 version to the 2015 version. And if you could kind of give us some feedback here on where you stand in regard to that, it may help some of the direction we take the discussion. And again, I appreciate your feedback. So let me kind of share with you what we're seeing. So there is fairly well-divided categories here. And then the second question is, which part of that migration is causing you the most, not just the migration, but also the having to deal with NFPA compliance, where you seem to be having the most grief. And hopefully some of our questions will be able to cover that, touch on that. So here's kind of we're standing there. And again, I appreciate very much your sharing that information. Okay, so let's jump into this. And as much as I enjoy demonstrating the tools, this list is actually surprisingly informative, both in terms of how it was developed, but in terms of summarizing the list for this report. So I'm coming to this topic with the assumption that the audience knows some basic facts. First of all, the NFPA 70E is the industry standard for electrical safety in the workplace, that OSHA will investigate accidents or incidents which result in employee deaths or hospitalization, and has the authority, if an incident is caused by or related to electricity, has the authority, if during the investigation find that the procedures or activity violates this standard, OSHA may assess penalties and fines under the the general duty clause that OSHA utilizes for its authorization. This list is compiled from dozens of regional workshops we conduct to expose new users to our software. The software is used to design and analyze electrical power systems. As much as possible, I try to cite specific articles to answer these questions posed. In a couple cases, I may offer an opinion, and in those cases, I will try to emphasize a focus on the solution that's based on improving employee safety, not just complying with the letter of the law. And so again, I'm trying to give you as much as possible perspective on where I'm coming at with this list. So first of all, frequently people confuse NFPA 70 and NFPA 70E. So what's the difference? NFPA 70 is the National Electric Code, and it's primarily focused on construction and installation and safety standards and what's referred to as building codes for electrical circuits, appliances, and machines. It is regionally adopted and thereby brought into the local building codes, and as a result, as work is done on older equipment or older building structures, there may be the potential for grandfathering in older structures that may not have been up to code at the time they were built. So those exceptions can be carried forward. With respect to NFPA 70E, it's the safety standard for the use of electricity in the workplace. It does not require approval by any other body or local organization, and there are no such thing as grandfather clauses. So if we have an old system, it has the potential to be judged or required to meet the standards as soon as the latest revision of NFPA 70 is released. In the past, there has been a little bit of confusion over which equipment actually needs labeling or warning labels, and so the 2015 version of NFPA 70E has been more specific, and under Article 130.5, the list includes switchboards, switchgear, panel boards, industrial control panels, meter sockets, meter enclosures, motor control centers. And there's also the caveat that only equipment that is likely to require examination, adjustment, servicing, or maintenance while energized needs to be field marked. So again, I've seen illustrations or examples where companies have set their own standard, which frankly is in many cases more restrictive or more specific than what the NFPA standards are. And it's obvious in those cases that their basis for that judgment for their local site was based upon improving employee safety. And again, I applaud people that take stances like that. For instance, we had a report that some chemical facilities in Houston, the technicians were taught to regard any piece of switchgear where there could be an interruption of electrical circuit had to have a label on it, and if they approached a meter panel or a switchboard that did not have a label, consider the label to have blown off, stop what they were doing, and then go find a remediation and the actual data that should pertain to that particular disconnect. So again, the point is the focus is not the letter of the law, it's making sure that we're improving our workplace safety. Next question, so what are the shock hazard boundaries as defined by NFPA 70E? Specifically, and these have been in place way before 2015, but there have been some changes just as of last year. First of all, there's a limited approach boundary, and that's defined as a location where there's a risk of shock existing. Unqualified persons may enter this area as long as they're under supervision of a qualified person or worker. And then there's a restricted approach boundary. Only qualified personnel are allowed to be there or within that boundary. Shock protection is required. And the distance in each of these cases will vary based upon the voltage at the exposed conductor. In the past, there was a third boundary referred to as prohibited approach, and as of 2015, that boundary no longer exists. So where is the arc flash boundary? Again, both in the definition and in Article 130.5b, NFPA 70E specifies the arc flash boundary shall be the distance at which the incident energy density equals 5 joules per centimeter squared or 1.5 calories per centimeter squared. So again, this is the distance at which unprotected skin would have a 50% chance of developing a sunburn or a second-degree burn. So there's a correlation between damage to humans and that particular boundary, and that's kind of the common denominator in most of the incident energy calculations and definitions. May I use the table lookup to determine arc flash PPE? Again, an area that's been in NFPA 70E discussion for several iterations, and as of 2015, there's been more specific direction in this regard. The answer is yes. Tables 130.7, C15 specifically, and 16 may be used only if specific tasks are to be performed, actually appear in the tables, and the system meets the listed criteria for the short circuit magnitude and speed of the response of the circuits, and the system meets the overall requirement that it can be verified the equipment's been properly installed per manufacturer instructions, the equipment has been properly maintained per manufacturer instructions, and there is no apparent evidence of any pending malfunction in the equipment. So there's no dripping water or standing water or buzzing or sparking or anything that would be obvious as you approach the equipment for the task at hand. Now take note, and that is the technician or electrician who will be doing the work has a responsibility to evaluate any and all of these elements, not just this page, but the prior page. And if the employee has a responsibility of making an assessment on their own, the employer is required to ensure that the employee is trained, and again, in this case we're talking about qualified workers, is trained to understand and assert this judgment, which goes to the heart of, I think, why we're having some of the changes in 2015 and why we're having this discussion. So then, by inference, there's actually two ways now to determine PPE required for any work. First is the table lookup, the second is calculating incident energy. So the question arises, which is the preferred method to determine PPE table lookup or calculations? And heretofore, the assertion was that NFPA 70E doesn't really take a stance, and by virtue of the two previous slides, I think, and this is my opinion, and it's been echoed by others in the industry, the new provisions make it clear that the intent of the standard committee is to encourage the use of engineering analysis over the table method. I love this one. So what is the difference between the HRC and the PPE categories? NFPA 70E 2015 specifically has deleted and described the hazard risk categories as no longer a valid reference and describing or referring to PPE. So it just ain't there. Just take it all off the registry. Take it off the books. PPE categories are the levels of personal protective equipment which can be used with the table lookup method of estimating required level of PPE. So just a side note, when it comes to labeling, if you have calculated incident energy density, neither of these terms should appear on the label. Okay, so frequently the question arises, my labels have PPE and incident energy both. Does that mean they're non-compliant? According to Article 130.5, labels that were accurate when the study was completed are outdated as of 2015, but that does not make the study non-compliant. And again, this is my interpretation and reading of those specifics. Labels should be replaced as the study is renewed sometime within the 5-year limited or the recommendation. However, if system changes have been made since the labels were put up, then one, the study is no longer valid because it must be updated with major changes to the system or system changes. And secondly, the labels are no longer valid because of that change and they must be updated. So there's some overlapping responsibilities here. As soon as I covered that discussion, the next question that pops up is, what are you talking about? Labels can't have incident energy and PPE categories on them? Answer is correct. Article 130.5, paragraph D, the labels shall contain the following, and this is the 2015 version: nominal system voltage, arc flash boundary, and one of the following: incident energy and working distance, or the PPE category from the lookup table if we use the lookup table method, but not both. So if we use incident energy, we cannot use the PPE category, and don't even think about talking about HRC. Or, so one of the following. That's the first option. The second option is to show the minimum arc rating of clothing that's recommended, and this is ATPV. And then our third option is to include the site-specific PPE that we've determined from our own for our own policy, company, and standards, and that's what we train to. So the question arises, okay, so we can't use HRC, we can't use PPE. How does a technician know what PPE to use? Well, this brings up the arc thermal protective value. ATPV refers to the maximum incident energy in calories per square centimeter that protective equipment can be exposed to and prevent the onset of a second-degree burn. These ratings are based upon total weight of the fabric. The appropriate clothing varies from flame retardant treated natural fibers with a fabric weight of at least 4.5 ounces per square yard to untreated clothing worn in layers. So when it comes to PPE, all my labels refer to HRC categories. All my PPE refers to HRC categories. All PPE vendors refer to HRC categories. What training do I have? And this is a common stance for a lot of companies that have been doing their best to keep up with the changing conditions of NFPA 70E. Frankly, in my opinion, this is where the discussion about labels and PPE, the point in the discussion where the rubber meets the road. in terms of changes to the 2015 regulations. And I come back to making sure that the worker safety is the basis for your decision rather than a fixation on compliance. So one reason for these changes is that people are still being killed and injured by this hazard, which is arc flash. And the great majority of the fatalities include qualified workers, the very people who should know what's going on. The NFPA 70E 2015 release is very specific about not putting incident energy and PPE categories on the label. Some PPE manufacturers are slow to get around to focusing on ATPV. So what's missing in the equation? The regulations are aimed at connecting the dots. The person whose very safety is at risk should know how to verify the PPE is adequate to the task at hand. So I may or may not be able to change my labels, at least in a short amount of time. I may or may not be able to relabel my PPE with ATPV very quickly, but I can start with the next safety training meeting explaining the change in procedures and how we as a company, how our policy will be changed, how our training will be changed, and what we're going to do in the meantime as these changes are being incorporated. So if your company has a documented plan and a timeline to deal with this label migration, and the document steps are taken in that, and we've documented the steps taken in that direction, I believe you're moving in the desired direction of the intent of improving worker safety and better training. Now, sorry if I got on a soapbox there, but this is kind of an area that I'm very supportive of after working in an ISO environment and being included in several ISO audits as an auditor and sometimes an auditee. I believe that there is a lot of credence paid to procedures and evidence that we're following the procedures rather than just the strict guidance of the letter of any specific regulation. So I think if the intent can be shown that we're moving in a direction of greater worker safety, and that's being led by better education of the employees, I think you're winning all the way around the block. Okay, if we use a contract, I love this one. If we use a contractor for facility maintenance, does NFPA 70 even apply to me? NFPA 70E back in 2012, Article 110 said, employers shall document meetings with contract, I shall not. Employers must document meetings with contract employees in which information about known hazards is communicated. Now this is more than just the hazards for electrical hazards. This is any hazardous material or condition in the plant. So also stipulated in OSHA 29 CFR 1910-269 requires divulging incident energy levels for contractors. So you don't really want to go to the place, well, I didn't know it was a hazard, because if you spend as much time going through the case studies on the OSHA website, you can see that that kind of stance falls into the area of willful disregard, which is a term that OSHA views very sternly upon. So again, taking steps to understand what hazards exist and then making sure those are communicated to employees, including contract employees, is well documented as a requirement. So what does NFPA say about maintenance, specifically 70E? Articles 200 through 250 are very explicit, talking about facilities must maintain current single line diagram. As of 2015, equipment owner is responsible for equipment maintenance and documentation. We must maintain all electrical equipment per manufacturer's instructions or industry standards. Previously, this requirement was only for protective devices. And again, this maintenance must be performed by qualified workers. And then document and test all maintenance on protective devices to even further degree in terms of the protective devices themselves. So what's the difference between risk and hazard? Again, this is an area that's been discussed in informative indexes attached to the standards, and more it's being pulled into specific requirements for NFPA 70E. But hazard refers to the potential for harm from exposed energized conductors. So in essence, it's the system's potential energy release in a worst case situation. The risk of that hazard causing harm or damage is the combination of the likelihood of occurrence of the injury and the severity of the injury resulting from a hazard. So there are multiple variables, and NFPA 70E has an extended decision tree and metric system for not only assigning or weighted levels to the different risks involved, but places the burden upon the facility owner to incorporate that in the decisions that are made about the system's safety condition. So where do I need to assess arc flash hazards? According to Article 130.2, all locations where voltage is greater than 50 volts and there is a possibility of performing energized work such as maintenance, diagnostics, and testing on exposed conductors. When is energized work permitted? Article 130.2, paragraph A. Only 3 cases where additional hazard or increased risk would result if we de-energized the equipment in question, or if the work that needs to be done is infeasible. In other words, we need to make some sort of a test on the equipment running or in energized condition, so consequently we can't approach it when it's de-energized and complete that work. And then third, energized work is permitted if the equipment's operating at less than 50 volts. Who's responsible for updating labels? Article 130.5, the owner of the electrical equipment shall be responsible for the documentation, installation, and maintenance of field-marked labels. That's why more and more we see as facility managers purchase equipment, they require at the point of handoff or transfer of title correct labeling, because in some cases they may not have the ability to incorporate or make the modification themselves. Can I put multiple layers of PPE on? Can I put on multiple layers of PPE to achieve higher protective levels? In the informative annex of NFPA 70E-M, the answer is yes, but a combination of layers that we expect to use needs to be tested so that we know the rating. It's not automatically put on 2 layers of category of 2 calorie equipment gives me 4 calories. We need to be able to test that result before we can confirm or use that particular combination of layers. And it's possible to send in test samples to a test lab and verify that. M3.1, the total system arc rating is the arc rating obtained when all clothing layers worn by a worker are tested as a multi-layer test sample. Does the arc flash boundary exist when the panel cover is still in place? Again, Article 130.5, if the equipment's been properly installed, properly maintained, all the covers and doors are closed and in place, then the arc flash boundary does not exist. What about DC systems? In NFPA 70E, Article 320.3, paragraph A1, prior to any work on a battery system, a risk assessment shall be performed to identify the chemical, electrical, and arc flash hazard and assess the risks associated with the type of task to be performed. Very specific directions in NFPA 70E, more extensive than even the requirements of IEEE 1584, which is yet to deal with the DC arc flash calculations. Do I need PPE to operate a circuit breaker? According to Table 130.7CA, no, as long as the equipment's properly installed, properly maintained, equipment covers and doors are in place and secured, and there's no evidence of impending failure. However, arc flash risk assessment, if we've done an arc flash risk assessment, let's say we're in an older facility, we find that we have an elevated incident energy behind a closed panel, and we require frequent operation of a circuit breaker that we understand the energy behind that panel means there's a higher potential risk of danger. And again, this is a combination of risk and hazard. The open and closed procedure may require specific instructions. For instance, the operator not stand in front of the panel directly, but stand to the side, not face the panel, and have PPE protection specifically on that side of his body, including hearing protection. So we may have a situation like this where the operator will be operating a panel, and yet he's taking, a circuit breaker, and he's taking specific steps to mitigate a problem that we understand because we know more about our particular system. Does online training count for qualified workers? Article 100 in the definitions log describes qualified workers having demonstrated, in the past it said familiar with, but now it says demonstrated skills and knowledge related to the construction and operations of electrical equipment and received training to identify and avoid hazards involved, including correct use of PPE. So the only reason I bring this up is if that can be done with an online training system and you've documented it, then you've met the conditions of the standard. On the other hand, if you're the facility owner or the maintenance manager and you want to see your qualified workers demonstrate specific skills, that would be tough to do just with online training, in my opinion. So now the most frequently asked question after all of this, there are several high energy buses in my system. Can you recommend a place to start to reduce the danger or hazards that are being projected by this study we've conducted? So at least once during the workshop this question will come up, and the recommendation or my offering may surprise you, or at least a few of you. The answer, in my opinion, is energized electrical work permits. According to paragraph or article 130.2 paragraph B, when work which involves repair or replacement of components is planned within a limited approach boundary or exposed energized conductors or circuit parts, and an increase of risk of arc flash exists even with the doors closed and covers on, a hot work permit is required. So many of us initially thought that hot work permits were just a necessary piece of paperwork that's required by regulations. And while that may be, while it may appear that way, the original intent and purpose of a hot work permit is to provide a standard procedure to complete the necessary work in the area of an elevated hazard and to do it safely. Now, frequently, that procedure may include specific steps to temporarily lower the incident energy, complete the work, and then restore the system to a normal configuration. So now before anyone jumps on the computer and texts to me, "Great, Jim, send me a copy of a hot work permit," let me say that I'm not the person who can make that recommendation. Most often, even the engineer who designed the building may not be the best reference for this procedure. The first person I would turn to, and the person who best understands how the system, how your system works, should be the lead maintenance electrician, whether he or she is a contractor or not. It's that tribal knowledge of the system combined with a better understanding of how the arc flash phenomena affects the system itself has been the missing link. So now we may be able to do certain procedures without the necessity of a hot work permit. It's that elevated knowledge and understanding the knowledge of my system itself and what adjustments can be made even on a temporary basis that I want to make sure get incorporated in my procedure for doing hot work, that all of a sudden elevates this discussion from just being that of meeting the letter of the law to being focused on the safety of their workers. And I think that comes across during a discussion with the team about all these elements. So what's the recommended steps to comply with NFPA 70E? And specifically in Article 120, safety program review is suggested, which includes electrical safety, tag-out and lockout procedures, conduct an arc flash risk assessment, which involves generating an accurate single-line diagram, conducting a short circuit study and a coordination study, incorporating regular and prescribed preventive maintenance, arc flash training of my qualified workers and anyone who has the potential to be in the area, documentation that includes job descriptions and specialized procedures for hot work, then periodic reviews of all the above, including training, studies, and improving my overall plan. Now, so this is the list, the extent of my list. What I would thoroughly recommend for those of you in the audience that have not availed this free offer from EasyPower, this book has been recently updated. It's available on our website for download. It's been recently updated to incorporate the 2015 changes, and I highly recommend incorporating it into your planning and understanding of arc flash hazards. It's available on the easypower.com arc flash resource page, and I appreciate everyone for attending this morning's discussion. I'll review some of the questions in just a second. I do want to remind folks that we have regional training regarding arc flash hazard assessment tools in the Portland area later this year, in BC, and in Dallas as well. And for those of you that have an interest in understanding how harmonics and or stability issues may affect some of your systems, I'd point you towards registering for the harmonics and dynamic stability class, which will be in late October here in Portland. For those of you that own the tools, you're welcome to avail tech support at easypower.com for tool-related questions. And for those of you that would like an expert review of your files as an EasyPower user, be more than happy to provide that service on an hourly basis for just time and materials it takes for an engineer to review those files. Thank you for joining us, and this session will be recorded and available on the website later in this week. And I'll check back frequently. We have several, in my nerdy opinion, several exciting webinars coming up in the Thursday series in the next few months. So I invite you to check back frequently for those. See you next week.